So the last class we discussed about the increasing and decreasing function, and we have seen that what are the conditions when the function is strictly increasing, and the condition in which the function is strictly decreasing. And we also saw that how the second derivative can give us the idea about the concavity or convexity of a curve.
Hello,
So
sir.
yes,
Sir, please, yesterday, yeah, because of network issue, sir, you said to attend next the cloud class. But sir,
mm,
I didn't. I got the message very late, and I thought the class is over. So I really didn't
okay,
join to. Sir, please will you again solve the second derivative problem? So
yeah,
yesterday's
yeah,
last one.
okay. So yeah, I think I started the lecture again just for the removal of doubts. So I think if okay, what is your doubt? Okay. If you ask, then I can help you.
So, sir, please will you solve the derivative, second
Okay,
derivative?
okay, fine, fine. Look at this. So look at this. Let's say this is also a quadratic curve. So that's very easy to understand intuitively also. So y is equals to 4x square minus 6x plus 12. Let's say this is the equation given. Now, if you find the determinant, sorry, discriminant of this equation, the discriminant will be how much? B square minus 4ac, and this is going to be negative number, right? So even if I write it, this is negative. Now, what does it mean? If the discriminant is negative, what does it mean?
So there are no real roots. No real roots.
Correct. So there are no real roots, and the y is always positive because the y is or the graph is always above the x-axis. That's the meaning, right? So when we have a negative discriminant, it will never cut the x-axis, and therefore the graph will be above the x-axis. And because the graph is above the x-axis, so y is always positive. Y is always positive. Okay. Now let's try to do the same thing with the help of calculus. So first of all, we'll find the derivative, first derivative dy by dx, and if I differentiate dy by dx, what you can see, we'll get 8x minus 6. So let's equate this to 0, or we can do it later on. First, let's find the second derivative. So the what is the second derivative here? It is just 8. Now, second derivative does not depend on any particular location or any particular point. It is a constant number and it's a positive number. What does it mean? It means the graph is going to be concave up. So because second derivative is positive, so this will be concave up. As you can see, this is concave up. Oh. Now, second thing is when the graph is increasing. So for a strictly increasing region, strictly for a strictly increasing region, the dy by dx must be positive. Because if the graph is increasing, then slope will keep on be, I mean, it will remain positive all the time. So this will give you the idea that x is more than 6 by 8, which is equals to 3 by 4. It means at 3 by 4 and beyond, it is always increasing. You can see that the graph is in the increasing mode if you go towards the right of this. And if I write dy by dx less than 0, which is the decreasing region, so what we'll get is that x is less than 3 by 4, and that is obviously when you coming towards the, if you come from the left towards this point, the graph will decrease in value, and if you go right of this point, the graph will increase in value. So 3 by 4 is a point at which things are turning, and the second derivative is an independent test, so it always gives you whether the graph is going to be concave up or concave down. And because it is positive for all values of x, because it is independent of x, so we can say that the graph is always concave up there is no part of the graph which is concave down or something else. So the second derivative test gives us an independent value called the concavity or convexity of the graph. Okay. And increasing and decreasing only means when the graph is growing in value and then the graph is decreasing in value as you move along x. So you can see that second derivative is positive, concave up, and first derivative is positive for all values of x which is more than equals to 3 by 4. So not equals to more than 3 by 4, and it is decreasing for less than 3 by 4. At 3 by 4, the slope is 0. Okay, so at
So,
3
but
by
how did
4,
you get 3 by 4?
pardon,
So, where did you get 3 by 4 from?
from here, if you equate this to 0, or you could just write this equation. So what you can get right here is dy by dx is how much? 8x minus 6 is positive. So we have to solve this inequality. So we can write 8x is more than 6. So x is more than, right? And similarly, if you write 8x minus 6 less than 0, 8x is less than 6, and therefore x is less than.
So this is part of inflection. No?
No, no, no. This is not the point of inflection. Point of inflection comes when the d2, the second derivative,
Also zero.
goes from, yeah, no. So yeah, that second derivative becomes 0, and it goes from the concavity to convexity at some point. So when it is 0, and it is, let's say, at one point it is 0, and before it is positive, and after it is negative. So if it is negative before and positive after, or vice versa, and it is 0 at the point, then that point is called point of inflection. If it is 0 everywhere, we say straight line. Okay. So this is the idea of the first derivative test of increasing and decreasing function, and second derivative test of concavity or convexity. Okay. So concavity and convexity is a part of a graph drawing actually. So what we can do now is, now I will teach you a graph before going to the last topic of differentiation, and that is called the dy by dx as a rate measure. Or maybe we can do the rate measure, we can do graph in the end. So that's fine.
Sir,
Yes.
can you show the previous page for just 1 minute? I want to copy.
Yeah, fine. So how is the tutorial session going on? I hope you guys are learning a lot from there also. Hello, hello, hello.
Yes, sir.
Yeah, I asked one question. How is the tutorial session going on? I hope this is done, this page.
Sir, over here we got d less than 0 and then how y greater than 0.
D less than 0, it means your discriminant is negative, which means it will never cut the x-axis. Now imagine you're trying to draw a graph which never cuts the x-axis. How you will draw? Imagine if you think I can draw like this. No, if you draw like this, it will cut eventually. Okay. If you draw like this, it's cutting. If you draw like this, it will not cut. So there are two options in which you will not cut the x-axis. Either it is like this or like this. There are two options actually. Okay. So now, out of these two options, we have to check the A. What is A of this equation? A is positive,
Positive.
right? So we'll choose this one. If A is negative, we'll choose this one. So imagine a quadratic. Every quadratic represents a parabola, and the parabola can be of four types: one, two, or you can say three like this, or the fourth one like this, like this. There you can say six. So out of the 6 options, let me eliminate one by one. Here the discriminant is negative. It means it will not cut the x-axis or it will not touch the x-axis. So which of the following 6 parabola we have to remove?
Left 3.
We have to remove the 4 one, right? 1, 2,
So,
3, 4. Because it should not touch the x-axis, right?
but
Neither it,
but
yeah,
if a equals to a is greater than 0, then it is an upward open parabola. So we have to eliminate the downward also.
correct. So now this is the right answer. So the moment you see any equation, you can exactly know that which graph will be correct and which will be wrong by looking at the discriminant and looking at the a value. So that is sufficient. Okay, and that is how we plot the graph also. So I will teach you how to plot the graph. Anyway, this is done. Okay, so next we are going to learn the last topic of the different you can say dy dx concept. This is called dy by dx as rate measurer. D by dx as a rate measurer. Okay. So what is the rate measurer? And what is the rate at all? Like, what is it? What when we say the word rate, what does it mean? So you go to some okay. What is rate? Yeah, you say something. Tell me again.
It's a change with respect to time.
Okay. So rate is basically a concept in mathematics. Also, you can say in physics, everywhere it's a concept, which means something per unit value. Something per unit value. Let's say you go to some maybe you can say a sweet shop, and you ask for the what is the price of this some sweet dish. Okay, you ask the price. What is the price of rasgulla or maybe gulab jamun? Then they put the price tag which says that 25 rupees per piece. Okay, so the 25 is the rate, which means it is for one piece of gulab jamun you have to pay 25 rupees. So rate represents the value of something per unit. Okay, per unit is for one value. How much you pay for one? Okay, so that's called the rate. So when I say the word rate, I mean of course change in something per unit time in physics. So in physics, the rate is change in anything per unit time. So rate is always defined this way. It is the change in anything per unit time, and that is called rate. Okay. So now how we put this in word, but it is not necessary that rate only means this. So this is actually called time rate. But we can have some other rate. Let's say I say something unknown rate. I don't know what is something. So then is change in anything per unit unknown. I don't know what is this. So it is maybe something. So when I write time here, so it's time. When I write something else, then something else will come. Now the idea is without saying anything, we always refer to time. So if I'm not saying anything, then what you will assume? You will assume time itself. Okay. So when we don't say anything, we take time. But rate is not only restricted to time. The rate is also taken with respect to distance. It may be taken with respect to velocity. Okay, it can take any variable. It need not to be just time. But as long as I'm just saying rate and I'm not mentioning something else, you are supposed to take time. Okay, so the rate dy by dx is of course change of two variables. So let's say I choose one variable as maybe anything y, and the other variable is time. So what I can do is I will mention something here. So let's say there is a particle which is moving along the x-axis. Imagine. So I draw the particle like this. So at t equals to 0, the particle is here. We can say x naught. And at some time t, the particle is at x. And at some time t plus dt, which is very small time interval, the particle is at x plus. Oh, I can make it like this. So t plus delta t, the particle is at x plus delta x. Now this is what we are interested in. So to go from x to x plus delta x, how much time it took? To go from x to x plus delta x, how much time it took?
Delta t.
Correct. So to go from x to x plus delta x, you took time delta t. So since the interval is large, so we define average rate equals to delta x upon time. So this is how we define the average rate in mathematics or in physics, wherever you can ask. But we are looking for something called instantaneous rate. Like I want to know at what rate you are moving at one particular instant. So there is something called in physics instantaneous rate. So what is the instantaneous rate? It means I want to see the change at one particular time t. So there is no way to actually find the instantaneous rate. That's very difficult to find in physics. So we have to understand one concept. So I want to know that how fast you are moving at this instant called t. This is what my question. Okay. Average means how much you moved and how much time you've taken. So when we divide, we say this is the average way of motion. But in that delta x, you might have moved slow and fast, right? So I have no idea how you exactly moved over the duration of delta t, whether you were moving uniformly, non-uniformly, fast, slow. I don't know. I have no idea actually. So that's why I'm asking how fast you were moving at t. I want to know only at t. So how it is possible to find it? The answer at t.
X by t.
Pardon?
X by t.
No. You can't write like that. Okay.
So we can take the value between the just the number after
Yeah.
the time.
Correct.
But
See, yeah.
if we the means the difference between t0 and t, then afterwards it will come t only, right?
Yeah. So the idea is, if I try two interval which are very close to each other, and if I try to find the average of that interval, it turns out to be instantaneous value, right? So let's say let's say you're running on a track and uh, the race starts at 10 a.m. exact 10 a.m. At the right moment that 10 happens, the athletes start running towards the destination. Okay. So now at 10 a.m. you start your motion. Let's say I'm interested, and let's say it's a 100-meter sprint race, and all athletes are equivalent of Usain Bolt, so they will finish in maximum 10 to 12. I mean 10 to 11 seconds. Okay, the 11 second is upper limit. Then they will all will finish mostly. Or you can take let's say 12 seconds is maximum. So everyone is going to finish the journey from 10 a.m. to 10 a.m. plus 12 seconds. That's over. Now I am interested in knowing the speed of Usain Bolt at 10 plus 4 seconds. Like when 10 is passed and after 4 seconds, what is his speed? I am interested in knowing that value. Now, to understand that at what rate he is moving forward, we need to find the displacement of the Usain Bolt in a time interval. So let's say I take a time interval from t to t plus delta t, and then I check how far he has gone. So I found that he has gone from x to x plus delta x. So the rate at which he is moving is delta x upon delta t, but the question is different. My question is, what is his rate at just t only, not from t to delta t plus delta t, just at t. Now this question is slightly difficult to answer. How I will know how fast you're moving at t? That's the question. You have to imagine that what you will do to get your rate at that time.
So
So, yeah,
maximum.
pardon?
So you mean the maximum speed or?
No. I mean the rate at 4 seconds, not between 4 to 5 seconds. So this is like a question like this is maybe 4 seconds, this is maybe 6 seconds or 5 seconds. Imagine. So in this duration of 1 second, you have traveled this much. Okay. So in the duration of this much, you have traveled this much. So when you divide the displacement and the distance you traveled upon time, so this is called average rate. The rate defined for the entire interval. Okay. Understood?
Sir, so now what do we have to find?
So now the question is different. Now the question is, what is your rate at just t? And there is no way to find it. You can never get the answer. That's the answer. The answer is we will never get the exact value at t. That's impossible to find. Why we
Sir,
cannot get?
why?
Yeah, you may ask why. Now at t, it's meaningless. Okay, I'm like I don't know how much you have traveled, and I don't know how much you have taken the time, because we only know one thing, that rate is defined as the change upon time. So unless I will not see any change, how can I divide by time? So you need to give me some time, and you need to give me allow me to measure the displacement, and then I will divide to get the answer, right? The problem is we cannot define the value at one instant. We can define only for between two instant. Now the idea is how we can convert the two instant into seemingly one instant. What we can do to achieve this task? Yes, that's right. So now let's try to understand this fact. In physics, this is a most difficult part to actually grasp.
Sir, but if it's very small, then we can use del x by del t. No?
Correct. Very good. You guys are getting it. So what we do is we just close the interval. I am looking for t equals to 4 seconds. So I will take 2 time 4 and 4.000000000 infinite like one. Now when we have two intervals which are really close to each other, then the gap is called dt, and the displacement is called, we all know this is called dx, right? So if the interval is shrinking to almost zero, then when you try to find the average of this interval, it turns out to be instantaneous value, because the time is so small that I believe that the Usain Bolt cannot change his value for that duration any by any significant amount. So whatever be his rate at this instant will remain same over this interval, and therefore the average turned out to be instantaneous when you reduce the interval. That's the idea of the rate. So what we write is that instantaneous rate is nothing but the average rate when the limit of interval of duration tends to zero. That is the definition of instantaneous changes in physics. It's not only rate, any instantaneous change we define from the average as a limiting case of delta t tending to zero, and this is the most important concept in physics. So what we need to understand or realize that you cannot find the exact value of any time instant. That's impossible to find. So, but if we can find a close value, which we expect as accurate as possible, and to find that value, we take a smallest possible interval. We find the average of that interval, which turns out to be average, instantaneous. My bad. So that is the idea behind the instantaneous and the average. So average means a big interval. Instantaneous means a small interval. And how small? As small as possible. The interval must be approaching zero. That is the limiting case, the right hand limit. If you remember the right hand limit, the left hand limit. Okay. So in physics, only two things you need to remember: the average versus instantaneous. Both are average, but one is the average of big interval, and the instantaneous is, you can say, the average of small interval. So when we have average of very small interval, we call it instantaneous. I hope this is clear to all of you guys, because this is the most important concept in physics. So is this clear? The average versus instantaneous.
So how can we write it in another form?
Yeah, so I will tell you.
Limit.
So the instantaneous rate of variable, you can name it any variable, of any variable, maybe what do you need, x, is defined as delta x by delta t limit delta t tends to zero. Now when delta t will tend to zero, so it's good to say this as dt. And when time is very small, then delta x will be also very small, so we can say dx. So it will turn out to be a derivative formula, but the variable by which we'll differentiate is called time. So this becomes the dx by dt, and this will act as the instantaneous rate of change of variable x. So we have instantaneous rate of change of variable, this box, I don't know what is this box, we can write as d by dt of the box. So you can say instantaneous rate of change of anything, and then d of that thing upon dt. That's it. That is the meaning of instantaneous. And this is what you have to remember. Okay. So instantaneous means when you try to define something at one instant, and average means when you try to define something for over the interval. So when
what would be given
the
in the box?
pardon?
So what would be given in the box?
Oh, that you will come to know. Just wait for one moment. Correct, exactly. It's impossible to find at one point, because see, it is like you're asking the rate and you're not talking about the changes. It's impossible. The rate means change of something upon time. So when you want to see the change, you need to observe over interval, and then you can see the change, right? Let's say, what was your height 10 years back? Can you guess? And what was your height now? So I believe that there must be some change between the two interval, isn't it?
Yes, sure.
Okay, now this is a really large interval, right? So 10 years is a big interval in which we can easily see the changes, and then we can say the average rate of change of your height with let's say respect to years. So I will take the year as the fundamental unit. So what is the rate of change of your height per unit year per year? So you can say maybe I was 3 foot, 4 foot. How much you were? 4 foot? No, not that much. Maybe three is maximum. So 10 years back, how like big you were? Do you remember? I don't know anyway. So I'll just take a rough estimate that right now you are, let's say, 5.5, maybe 5.6, 5.8. So I'll take the average as 5.7, or maybe just I'll keep it integer. Let's say right now you're 6 foot, and you for 10 years back you were 3 foot. So in 10 years, how much change you got? 3 foot. The change is 3. So I can say 3 by 10 is the rate of increment of your height per year. So 3.3 feet per year is the rate. Now, if I ask you, what is your rate now? See, it's very difficult to say because the height of yours today, and in fact, even if I take one complete day tomorrow, what do you expect the change? The change will be
Very small.
almost negligible. You can't even feel it. Okay, so if someone will ask you how long you were yesterday and today, then certainly the change is invisible. So that's called, if I get somehow this value, the smallest value, then I can tell you your instantaneous rate. But since it is impossible to get, so we only shift to the average rate. Okay. We can only say the average rate. But let's talk about something called the growth of bacteria, or the rate at which the cell divides itself, the mitosis or meiosis, which you study in biology. So they grow really fast. Okay. So their instantaneous rate, in fact, rises exponentially. So the rate they will grow is very fast and tremendously fast, and their instantaneous rate is something which we are interested. So to find the instantaneous rate, we do only one thing. We only find the average because that's only possible. But you keep on reducing the intervals, and when you measure the average for really small interval, then that becomes instantaneous. So the idea of instantaneous comes from where? The idea of average. So you can say that there is nothing called absolute idea of instantaneous. So what is the idea? Idea is for average is known to us, and from there we try to deduce the idea of instantaneous by reducing the interval, and that's why we write the derivative. So what you can remember? You can remember that when you write a derivative, the dx by dt, it represents instantaneous changes. But when you write the delta x upon delta t that way, that represents the average changes. So this distinction must be in your mind. Okay. So let's see something in physics which you can express in terms of a rate. So we have something called velocity. So let's say you're moving along a line. I can say like this. So you're moving along a line, and this is, I can say, x-axis. And as I said, so at some time t equals to t, you are here called x, and then at some time t equals to t plus dt, you are at x plus delta x. So the average velocity, how we can define? The velocity is defined as the rate of change of displacement. That is what you have learned in class 9. So what is the average velocity? So
Delta
here
x by
the
delta t.
yeah. So here the average velocity is the displacement over the time upon the time. That's simple. Now there are ways to represent. So we can write as v average delta x by delta t. So if you read the Russian literature, they use a very nice symbol called the angle bracket. So they put in between the angle, and when we put something like this, it's called average. So this is a very different bracket called angle bracket. So you have anyway multiple types of braces. So you know parenthesis, curly, and the square. So now this is the fourth one, the angle. And the fourth one we use for the notation of average. So this is a very famous way of representation in most of the Russian literature, and now it has almost come into the our own representation also. So we also use this way of representation. Okay, so that is idea.
So what are the difference between delta del and the smallest one?
Pardon?
Sir, what are the difference between delta del and the last सबसे छोटा वाला
Delta.
del and that so the last symbol.
This is T delta delta. This is on delta only.
Sir,
This
no,
is called
we write delta no. So there are three ways to write delta. So delta del and one more is there.
Sir D, he's talking about the delta T and del. That's why.
okay. That's partial derivative. Okay, you're saying this
So
is
what is difference between them?
okay, I'll tell you like this. Imagine your pocket money is equals to sum of money given by your parents. Okay, so let's say the contribution of your pocket money is money M. Okay, and okay, I'll make money something different. So let's say I'm taking this as Y. Now it is sum of money given by your parents. So let's say every day your mother gives you X and father gives you something other function of X. So maybe your mom is giving you every day 5 rupees. So I can say that mx is equals to 5 because it's not changing at all. But your dad is giving you first day 5 rupees, second day 10, third 15, and fourth 20, and so on. That's very interesting. I can say the f of x is
2 into
5, 5x. It's a multiple of 5, right?
yes.
And x is the number of day. X is the number of day. So I can say your total money is 5 plus 5x. Okay, so y is the total money, which is 5 plus 5x. Now imagine if we have multiple variables. Let's say if I choose this as x, this as maybe z, or it's better if I convert this into a better way. Okay, I mean, so there is same way of writing something. So let's say I say that someone is receiving some money which depends on multiple variables, not only x, it depends on x and y. Let's say I'm just writing it in a simplest way. So your amount will grow because of x also and because of y also. You can imagine like this, right? So let's say your amount depends on two variables, not one variable. So I want to know that what is the rate of increment of money because of your mother donation. Your mom is donating some money. So what rate your money is growing because of your mom? So you can say, okay, this is del z by del x. So you are taking only one variable. Maybe your mother is the only variable, and you want to see the effect on your money because of your mother only. You're not taking the father's contribution. So this is called the partial derivative. Partial means out of two variable which you have, which is changing you the value of y or whatever z. Yeah, it's very confusing. So when a function depends on multiple parameters, like z is depending on multiple parameters, two parameters, and you want to know the change of this because of this only, ignoring the contribution of the other, then use the partial derivative. That is the meaning of partial derivative. So if you want to know the change of z because of this variable, you write it del z by del y. Maybe it is a function of x, it is a function of y. So quite possible. You can say gy. So when something depends on multiple variables, then the concept of partial comes into picture. If something depends on only one variable, we take the exact differentiation. We don't use the partial. So partial means you want to partially check the effect of one variable on the dependent one, and you ignore the other one. Okay. So that is the meaning of partial. Understood?
Sir,
Yes,
but
sir.
at the end, answer will come same only because we do the vice versa to both the type of variables.
No, why it will be same? Let's say your dad is giving you as a function of x and your mom is giving you as a function of y square. And then your money is the sum of these two. Let's say. So del z by del x is how much? Your money is growing only one. This is one because if you differentiate this only, if you differentiate with x, so y will act as a constant. So you can get only one, which means the rate of growth of z because of x is one. So what is del z by del y? If you differentiate, you get 2y. So the growth of y with respect to the growth of z or z with respect to y is twice of y value. So that's
The
a
minus
relation.
6 upon 2y, right?
Pardon?
So del z by
Uh-huh.
so the whole value is del z by del x equals to minus sorry dy by dx is equal to minus del z by del x upon del z by del y. So answer will be 6. So is it 1? Then it is minus 1 by 2y.
No, no, that's a not different question. What you're saying is that's a okay. That's a different thing. Okay, you got it wrong here. So this is the formula of finding the y with respect to x. When we can convert that into a formula of this is the formula to I mean, calculate dy by dx. It does not mean uh, okay. This is different. This is different. Don't mix this with this. Okay. The partial derivative refers to differentiating the dependent. Let's say z is a variable which depends on function of x, y. Okay. So z depends on two variables x and y. Like this, you can write this way. Now, because it will change because of x also, it will change because of y also. So I want to know at what rate it will change because of x. That's the meaning of partial derivative. That's it. So del z by del x is the rate of change of z with x only. So I will not see the effect of y. I will ignore the y effect. So when you ignore the y effect, you take y as constant and you write like this. So when you write del z by del y, you ignore the effect of x. You just take the effect of y itself to find the rate of change of z. Okay. So these things are. Okay. I hope it will take some time for you to actually realize. So don't worry. The partial derivative is something very interesting, and it is called the multiple variable calculus. Because of course that's not part of our syllabus, but we should know a basic of it because we need this in particular chapter. So you will come across this in future that a variable can be like z depends on multiple variables. Maybe I can say x1, x2, x dot 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 xn. So this is called the n variable function. Z depends on these many variables. Now this is too much. Okay. So I can say like how to relate this. I mean, you can take one example. Let's say uh, the sale in the supermarkets during festive seasons and the sale in the supermarket during the normal season, and it changes a lot. So during festive season, the sale of sugar will grow exponentially because all is making some sweets at home. So every like supermarket knows that when it will approach the festive season, they will stock the sugar more because you're going to buy more. So they know in advance. So we can say the sale depends on various factors, depends on the time of year, depends on the locality. Let's say if it is the northern part of India, so we are going to celebrate much more about the Diwali or something more. But if it is south, then we are going to celebrate more of the Pongal or something like this. So if we are in the Maharashtra, we're going to celebrate the Gudi Padwa and all. Like so depending on the locality, the things which are being sold will change. Okay. So we can say that on what factor the sale of the demand of stuff or grocery in a given supermarket will change, and what kind of stock one should have. So here it's a study of called multiple variable function. So we have multiple variables, and there we need the concept of partial derivative. So of course it's an advanced thing that you will come across when you learn calculus in higher studies. If you take mathematics as your thing. Okay. So now coming back to the thing.
Sir, I
So
wanted to
you want to
in that previous thing we were drawing that velocity ka that number line something. So udhar
yeah.
it is d like up it is t plus dt or is it delta t?
Wait. That is I have done mistakenly. This is delta t. Okay. So t, and now let's say if you talk about the instantaneous rate or instantaneous velocity. So the instantaneous velocity is how much? V equals to
So delta x by delta y
so for instantaneous we just
of
write dx by
delta
dt.
y.
Yeah. So this is same as writing this. So that is how we learn in calculus, no? That this term we can write as d like this. If you remember the differentiation, what is dy by dx? If you remember, the dy by dx is limit delta x tends to 0 of delta y by delta x. This is called dy by dx. If you remember the derivation of the first class.
Yes, sir.
Similarly, everything when we take the denominator variable tending to 0, it becomes a small d. So this is always written like this. So the derivative is the limiting case of average. That is the real life scenario. So every derivative represents some average when the interval becomes really small. So average and instantaneous are closely related terms. One with big interval, we only say average. One with interval tending to 0, we preferably say instantaneous. So the instantaneous velocity is that average velocity when the time interval is approaching 0. And for everything which is instantaneous, we preferably write derivative dx by dt. So when I don't put anything, this is called instantaneous. Okay. So similarly, if I ask you, what is acceleration? What is acceleration? So again,
d
you
by
need to
dt.
ask, no, you need to ask Mr. which axis you are talking about, average or instantaneous. So
Yes, sir.
in your earlier class, you never realized that the acceleration which you have used to solve question, that was instantaneous acceleration, and that was average also, because that's called uniform acceleration. Uniform means when you do not change your value at any instant, you remain same throughout. So when something is uniform, then average value or instantaneous value turns out to be same. So we don't distinguish between the two. So the chapter which you learned in class 9th is called uniformly accelerated motion. So this is what you might not have realized, that the term uniformly was very important there, because that assured that things will not change over the time interval.
Yeah, sir.
In present physics, things are going to change. We are going to see something called non-uniform motion, non-uniform accelerated motion also. It means over the period the acceleration will also change. So what will you do if the acceleration is variable? Then you have to define average and instantaneous both. So the acceleration, when I say, you have to ask which one. So if I say average acceleration, what is average acceleration?
Delta v by delta.
Delta
Correct.
correct. Delta v by
Because
delta.
it's equal, yeah, it's called the rate of change of velocity. So you can write delta v by delta t. That's it. But if I ask you what is the instantaneous acceleration,
dv by dt.
very good. So the instantaneous acceleration we just write as a, and we write this as dv by dt. So a is equals to dv by dt. That's it. So we have two types of acceleration, and one is called the average, other is called the instantaneous, and a is equals to dv by dt. So now in physics, we cannot take things for granted. So when I ask something, then you have to always ask which one you ask, because now both possibilities are there, and we need to be very much clear about what we are going to ask. Okay. So what happened earlier will not happen now. So we going to face both things, and both kind of questions will come into picture very often. Okay, so let's see the next. So you have seen something called okay, so let's say you are moving on a path, some random path. So we talk something called speed. Although we have same symbol, but the context is different. So what is speed? How much you travel, right? How much you travel in terms of length of path, called distance. So speed refers to the distance traveled upon time, right? So distance is the length of path. What is distance? We know what distance is. We write distance as s normally because it's like curve. So we say s is the distance, and in context we can use both. I mean separately. So now distance is s, and this is t, and this is t plus delta t. So what is the average speed? So it's a very famous definition. We can write a total distance traveled upon total time taken. Right? Total distance traveled and total time taken. That's called average speed. So we can write delta v, the average speed equals to s upon t. Like in this case, s upon delta t. Or you can
So
say delta
delta
s.
T, no?
Yeah. So you can write like this. Now, if I ask you what is the instantaneous speed? Instantaneous.
ds by dt.
ds by dt.
Correct. So we can write ds by dt. So now you can see something more interesting here, although we will again learn in kinematics that if we have a curve path, like a path which is not straight line, and if I take a point beginning and the end point at far away, and if I join these 2 points, the length of a red line is called magnitude of displacement. The length of a red line is called magnitude of displacement, whereas the length of the path is called distance. This is your distance, but this is your displacement. Okay. So
Shortest
one is
distance traveled.
Shorter
yeah,
distance.
no, this is not displacement. This is called the length of displacement. There is a very confusion, too much confusion among students that they do not understand the difference between the two. I have told you that displacement is a vector. So vector will have magnitude and direction. So you can't say this is displacement. You can say this is the length of magnitude. And this is the magnitude of displacement. So the red line is representing delta r, called displacement vector, modulus. I can write better.
So this is curvilinear motion.
Yeah, this is curvilinear motion. Correct. So what we can understand that the distance, I will not write delta here. The distance traveled is s, and this is the displacement. Which one is bigger? So you can see s is more than the modulus, the magnitude of displacement. Now, what if the line is a straight line? If you move on a straight line, then both will be
Equal.
same or different.
Magnitude of displacement is equal to distance.
So we can say displacement is equals to
Modulus delta R vector.
We cannot say, see, you cannot equate distance with the displacement because the one is vector, the scalar. What you can say that S is equals to modulus of displacement. This is what we can say. Never used to say the word equal for distance and displacement. It is like one is the vector quantity, other is scalar quantity. So we cannot compare the two quantities, but we can compare their magnitudes. Okay. So now if I combine both situation, I can say S is always more than equals to. So this is the in general relation between the distance and magnitude of displacement, and this relation will hold every time. Okay. Now, what I am going to explain through this concept. Imagine the same situation, and imagine we are taking a tiniest part of the path. So, what is the tiniest length of path? We can say ds. Now, if I join these 2 points using a line, oh, the line is as good as
Equals a
ds.
straight line. Yeah.
So I can say that when things are really small, this is called elementary distance.
So like elementary angle.
Yeah. So if it is elementary distance called the smallest distance that you can imagine, then the dr called the elementary displacement modulus both become same. So there is no distinction between ds and dr in terms of value. So although s is more than equals to delta r, but what we need to realize that a small distance always equals the modulus of small displacement. So they are always equal. They don't follow inequality, they follow the equality. And here we have inequality. You can see that.
Sir,
Sir, what did you, can you repeat?
sir, this application of elementary distance is it used in parallactic method?
In
Parallax method for finding distance between celestial bodies or from Earth.
no, no, there we use the concept of angle only. So we take angle. Yeah, you can say that. You can say that because the path is very small, so we can take as an arc of circle. So although it's a straight path, let's say you're going this way or maybe you're going this way, but to the observer which is very far away from you, very far. So you can think this as a arc of circle. It may be a curved line like this, but you can think of arc of a circle, and this you can find the distance between the two stars. Okay. So you see the star from here, then you see the star after 6 months. So okay, that's very interesting. Parallax is very interesting concept.
Sir, yes, we have read about it.
Yeah, it's very. I will tell. I will tell.
Sir, can you repeat this again? What did you
Yeah.
say?
The idea is that elementary values are not following the inequality, they follow the equality. That's the difference. So ds is always equal to mod of dr, whereas the s is more than or equals to delta. So this relation and this relation is bringing some sort of idea, some sort of distinction that we need to keep in mind, that the big intervals will have inequality, but the smallest possible intervals will follow the equality. This is something very interesting for physics. Very, very interesting. Very, very important as well. And now it is why it is very important. So you will realize a bit later on that
So I have a doubt in the representation of vector values like you did delta R modulus with above vector sign.
yes,
So why it is I know matlab, uh, you said the reason why it is written like that, but means what on the basis that mod is added and the
mod means magnitude, because a vector will have direction also, right? So displacement is from A to B. So arrow is also there. So we can't compare the arrow with without something without arrow. Like you cannot compare how to do this. One is vector quantity, like which one is better fruit, mango or apple, and that's like depends on choice. You cannot compare the mango with apple in terms of taste, because I don't know which taste you like most. But if I ask you which one is the more costly fruit, then you can compare. You can say, yeah, apple is costlier than orange. So we can talk about we can compare the cost, but can we compare taste?
No, sir.
Yeah. So the idea is simple. Yes. Yeah. Correct. The principle of homogeneity. So what we can compare is something which we know, we understand. We cannot compare the taste of something. So similarly, if one is having direction, other is having no direction, then how we can compare one with direction and other without direction? We cannot compare the two as a whole, but we can compare their values, the magnitude, because both represents meters. Okay, some meter is there. So even you express the distance in meters and you express displacement magnitude also in meters. So I can say at least that which one is bigger, okay, which path is bigger than the other path. So
Or,
we're comparing the length. Okay.
so,
Yes.
sir, I got disconnected. Can you explain the right side part? I didn't hear anything.
Okay. So the right side part is simple. Let's say someone is moving on a curve path. As you can see, A to B, you go from A to B. So when you go from A to B via the path, blue path, this is the path. Okay. So when you go from A to B via this path, then how much you travel? You travel S. But imagine if you would have gone directly from A to B via some alternative path, then you have traveled only this much. So what we can see, if path is curvilinear, then S is going to be more than this. It could have been equal if you move on a straight line, then this could be equal. So if I combine these two and if I want to express as a single formula, so I can say S is always either more or equals to this value.
Sir, why
Okay.
modular?
The modulus means length. The if you know
So
vector will
we
have
added two
magnitude and
vectors,
direction.
right?
Yeah. No, the left hand side is a scalar. Distance is a scalar, and
Sir,
the right
to
hand side is a vector.
sir, to
Pardon?
manage the signs, because vector does have sign.
It's like, okay, can we compare like a 2 with 2 I cap? We cannot say they are equal. Is it good to say they say equal?
No, sir.
We can only say 2 equals 2. We can't say 2 equals to 2 I cap. This is wrong. So the idea is we can only compare the magnitude. So we can say that 2 equals to mod of 2i. This is right. No, this is right. So what is the mod of 2i? It is 2 only.
Yeah, sir.
So now this is the right way of writing. This is the wrong way of writing. Okay. So when we want to compare a vector with a scalar, you can't compare. That's a fact. You can only compare their magnitudes. The distance and displacement have a similar measurement called meter. So I can say that how big is that path numerically. I can't say the direction. I cannot compare the direction with someone who do not have direction. No, mod will not change the value. Mod will give the value. That's other way of saying. So modular symbol gives the value. Okay, it's like a way of writing. Just don't think much. So we'll see, of course, again in kinematics. Don't worry about it. So what idea you need to learn from here? That's the ds and dr are equal in value. This idea you have to understand from here.
Elementary distances have perform
Yeah. So elementary distance and the modulus of elementary displacement are always equal, What does it mean? Is something hugely impacting our learning. That if I write ds by dt and if I write a mod of dr by dt, if I divide by time interval, then what we realize, this implies that the instantaneous speed is same as modulus of instantaneous velocity. So that's very interesting. Leave it. I think this part is
So
not getting.
this elementary distance,
Acceleration.
Pardon? Yes, tell me.
Sir, if the time is equal,
Mhm.
then the acceleration will be also equal, sir.
Yeah, so you can say. I mean, what you're saying is I'm not getting actually. If time is equal, then acceleration is equal. What does it mean?
Uh, so if the object covers the dr and ds at the same time, in the same time, and we know that the velocity v both the v are equal, so then means,
No, I mean, of course, you need to go back to the definition of acceleration, which says that it's the rate of change of velocity.
so initial is always if we start from zero, then initial is
No,
always
no, 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 no. We can't
v.
compare something like this. See, everything comes with a definition, and you have to look from the eye of the definition before you say or comment about anything. So, if you want to comment on acceleration, see from the eye of definition. The definition says it is a rate of change of velocity. So, to compare, you have to understand what is the velocity first of all. Second is we have a speed versus velocity. So one is the scalar part, other is the vector part. But you will be surprised to know there is no equivalent of acceleration. Acceleration is only vector. That's very interesting. So scalar quantities are not defined for acceleration. So you may have distance and displacement. You may have speed and velocity, but there is nothing similar for the acceleration. Acceleration is only vector. It is not a scalar at all. Understood?
Yeah, sir.
There is no equivalent of acceleration. So we have speed and velocity. That's two different things. One is for scalar, other is for vector. We have uh, velocity, and we have, sorry, we have, yeah, speed. We have displacement. We have distance. But similarly, we do not have the same thing for acceleration. We have just acceleration. Okay. So don't worry about this. Acceleration is something very complex. Acceleration is something which is only defined mathematically. You cannot see acceleration. So when you drop any object, it falls on ground. Do you see acceleration or do you see displacement? What do you see?
So I didn't hear the question.
Displacement.
I'm saying that let's say you take some object in your hand and you just drop it. So it will fall on the ground. Okay.
Yes, sir.
So can you see the acceleration or can you see the displacement?
So acceleration will be same, displacement.
No, no, no. My question is, can you see? Can you see acceleration?
No, sir. No,
Displacement.
Can you see acceleration?
no, sir.
You cannot see acceleration. Come on, you can never see acceleration. That's the problem. Acceleration is only computed mathematically. It is not observed, and therefore you need to realize also in physics that observation is something very very important, and on the basis of observation we make our calculation. So the only thing which is observable in physics is displacement and time. So we have a device called timepiece, watch, something stopwatch, watch, whatever. So you can use that to see the time the ball has taken to reach the ground, and you can measure this length. And when you do so, you get the average. You can say average velocity or the average speed. So you can define those things using the observation. But you cannot see acceleration. No, 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 you can't see acceleration. So, sir, what we can do to see the or to find the acceleration? Yeah, you can do something to find the acceleration experimentally. What you can do experimentally? So you will divide the journey into equal time, like equal length. So let's say I cut this journey into 4 equal parts, and then I'm using the stopwatch, which gives me some time. So I have attached the clock one, clock two, clock three, and what we can see that as it passing the equivalent path, I mean the length, the clock is showing some time. So what I do is I start from t0 here. I got t equals to t1 here. I got t equals to t2 here. I got t equals to t3 here, and I got t equals to t4 here. Try to understand what I'm trying to explain here. That's very, very interesting and very, very far-reaching consequence. If you understand this, you are going to become a scientist. So let's say I break into equal parts d d d. Okay. Now try to find the average value of each interval. So for the first interval, what is the average v? You can say
So
d by t1,
D by D.
correct? Now what is the
So
average for this?
D by T2.
D by t2 minus t1.
Okay.
so that only I was saying. The T1 minus T0 will come. So
No, but
Correct, correct.
T0 is given that T0 is nothing but
okay.
0 only.
No, that's not same. See, the
No.
time is time shown in the watch. It is not the interval, it's a time. So you start from 0, then you get some time t1. So the first interval is this one. This is the second interval of time. Delta t is this much. What is the third interval?
D by D3 minus D2. T2 minus.
And what is the last one?
T4
D
minus
by D4 minus T3.
Correct. Now, what you need to understand that although I have got the idea that these are the average speed or average velocity, what we can see that if all values turns out to be same, imagine all turns out to be same, then we can say that the body is not accelerating, right? If everything is same, then we can say for sure that it's not accelerating because you're moving in the same way in all intervals. But if the ball is really accelerating, what do you expect? Which one is going to be bigger?
So the last one.
Exactly, because the interval will be really small because you will travel the same distance in a very less time because your speed is gone up. Okay, so if I name it to 1 or 2 and 3 and 4, and if I see one thing obvious thing that okay, this is less than okay, that's very interesting. Okay, anyway, I'll look at this. So now what we can say here that the ball is accelerating. So to say that the ball is accelerating, what we did? We calculated the average for small intervals. Okay, and that is how the scientific thing works. So if you are an experimentist, if you want to experiment, do the experiment as Newton did, as many great scientists did, then this is the way to understand the acceleration. Acceleration is something invisible. You cannot see acceleration. That you need to realize. We don't see gravity. We understand it, of course, it's there, but we don't see the acceleration to gravity. We don't see 9.8 meter per second square. We don't see it. Come on, we cannot see it. So, as an observer, my restriction is only limited to displacement and time. So that's the fundamental quantity. So displacement and time is a fundamental observation, you can say, not quantity. And we do the calculation in the reverse order. So from displacement time, we go back to velocity. And from velocity, we go back to the acceleration. So this is how we perceive the idea of acceleration through the reverse process. Of course, because of acceleration, we have velocity. Because of velocity, we have displacement. So we have a different sequence of event, but to understand the cause, we go back in, it's called the reverse time travel. So if you go back into the situation, then you realize that, oh, this is the acceleration. So if you drop a object from even seemingly bigger height, you will never realize that it's accelerating. It's difficult. Yeah, to understand the acceleration, you have to drop from really big height. Then perhaps you can see it's accelerating. So that's very interesting. Then if you
Sir,
can
in,
also
sir, in vacuum there is no acceleration. No?
in vacuum.
There is no acceleration. No?
Oh my God. So vacuum has nothing to do with acceleration. Acceleration is due to the gravitational pull. So vacuum means no air, but Earth is there. So although there is no air, but Earth is there, so gravity is there. Why gravity will go away? Is air
Sir,
creating gravity?
in vacuum, constant acceleration would be acted.
Yeah,
No?
in vacuum we can say the acceleration will remain constant. The air resistance will not work, so you will always accelerate. But
So
if
that
it,
air
yeah,
drag force will be not there. So
yeah, no, in vacuum you will accelerate, but in with air resistance, if it is air is there, then you will accelerate for some time, but then you will start moving with constant velocity called terminal velocity, and that is what is used by the skydivers. Okay, so those who are the skydivers, what they use is they use the concept of air resistance. So they know that they will not fall forever accelerating. So they fall, they attain some high velocity, but then again they experience the greater air resistance. So what they do is they spread their wings because they have a the kind of suit. I mean the which they wear
yes,
is having a wing. So they spread it, which increases the air resistance, and the increased value of air resistance will push you back. So you will never fall
lift,
down.
lift, no, lift force.
Yeah. So what they do is they keep on moving forward and backward by turning their body. So they are very much they experiment. Expert skydivers don't do it. You can, of course, you can't do it because there are only very few schools in the world which gives this training. So if you want to become a skydiver, you can go to maybe New Zealand is the best place for that. I think. Anyway, in India also they have opened some branch. So nowadays you can learn in Mumbai itself. Maybe Mumbai, somewhere. I mean, they have some kind of school actually. Okay, so anyway, the idea was to give you the idea that you cannot see acceleration. You can only see two things in your life, and from there you have to evaluate everything else. And that is displacement and time. So I hope that you can remember this fact. Coming back to the rate, okay, so we are talking about the rate, and we should stick to rate only. So now we have seen the rate of change of displacement, distance, velocity. So three things of three types of rate we have seen. So now we'll see some general rate concept. Okay, so let's see something more here. So I can manage one question in this box. Yeah, I can manage one.
So do we have to write this?
No, there's no need to write. You can ignore this. You can write if you wish. It's up to you. Okay. Anyway, I will be sharing the notes so you can see the notes in the PDF format. It's good to write everything for your own understanding. Okay. So now what we need to realize that the rate is of course a general concept. It's not only restricted to this. So let's see some more problems which is depending on the rate. So this is my favorite question. In fact, this is a very famous question of almost every book. So the question is, it's called the falling ladder problem. So I can name it falling ladder problem. So that's very interesting. So let's see what is this problem all about. So you can imagine there is a kind of a ladder, or maybe it's not a good color. So imagine this is the ladder of fixed length. Of course, the length is fixed. The length is L. I will use small L to write. It's easy. And this angle is a variable angle, but at instead of asking this question, this angle is found to be let's say 30 or maybe 60. And now someone is pulling the bottom of the rod with fixed speed, like constant speed. So someone is pulling it with constant speed. So I can say someone is pulling with maybe 2 centimeter, maybe meter per second. That's fine. So what is given to you? The velocity of the bottom of the rod or the ladder is given to you. So you know that this end of the rod, the bottom of the rod is moving with what speed? 2 meter per second. Okay. So now this is what you need to realize, that the bottom of the rod is going ahead with 2 meter per second. What does it mean? That in 1 second you are traveling 2 meters. That's, you can get the idea of basic idea. No, wait. So you have gone somewhere else. So that is not our question. The question is L is there. L is, let's say, how much is L? So I'll tell you the L value is given 13 meters. Okay. Now the question is, theta is not required in this case. I think we can remove the theta actually. Theta is not given actually. Now you can tell me one thing, that as the rod bottom will go right, the top of the rod will go
Now,
down. Where? So the top of the rod is going to go down. Okay. So the question is, at the instant the bottom is 5 meters away, what is the rate of top coming down? At what rate the top is coming down? So you can name it B. So the question is simple. Question is simple. Find VB, that is the velocity of B or the speed of B, when bottom is 5 meters away. So this is our question. Okay, so we can solve in many ways, but we have to learn the most fundamental way of solving this question. So I have
can we
to
try first?
Yeah, you can try. Okay, you guys can take some time, and then I'll come back.
Sir, please, will you explain the question shortly?
Question is again, we have a ladder of length 13 meters. Okay, someone is pulling the bottom of the rod with a fixed velocity of 2 meters per second. At the instant when the bottom is 5 meters away from the origin, what is the velocity of B point? That is, at what rate the B is coming down? That's question. At what rate B is coming down? That's it. Okay. The question is clear. Now I can think for some time.
Sir, sir,
Yes.
sir, and the 2 meter, the V is equal to 2 meter per second is the speed of velocity of A, right? Point A, right?
Yeah, correct. So velocity of A is the rate at which the A is going ahead from O, the rate at which you separate from O. So 2 meters per second means the point A is separating from O at this rate. That's the other way of looking at it. And the question is, at what rate the B is approaching O? So the rate at which the B is approaching O is called the speed of B.
Yeah, sir.
And we have to find the relation between the two. That's it.
But we have to find instantaneous VB.
Right. Yeah, correct. Instantaneous, exactly.
Sir, so we have to find that with ds by dt.
Do whatever you want to do. Then I'll come back. This is your try, so you can think or do whatever you want.
So, but I
Then,
wanted to ask you, how do we matlab solve, like we solve the differentiation वैसा only we have to solve.
we have to differentiate. We have to differentiate only using chain rule and all. So you know the chain rule, right? So okay, I'll give you a small hint. The hint is simple. Take this as x, a variable, because it is a variable, and 5 is the instantaneous value of that variable, which we have to substitute in the final equation. Choose this as y. This is how you start with, and then relate the variable with the constant, the x, y, and l. How we can relate?
Sir, y will be
You can use Pythagoras. So this is the equation from which you will start your question.
12. Y is
Yeah. So
equal
now, yeah, that is fine. That y is no y is 12 is for that instant, but right now, see the in general relation between the variables, x and y will always have this relation, no matter what is x or no matter what is y, right? X and y will always add up to this formula. This is always true. This is Pythagoras. So this is called the relation or the constant relation. So when we want to solve a question like this, in which we have some unknown, and some known, some unknowns. So what we do is we first relate them. So we either find some mathematical relation to relate them, or some maybe it's algebraic relation, maybe it's a trigonometric relation. Whatever relation you can come across, you have to first make the relation first. You write the relation between the variables and known, and then what you do next is differentiate this with time. So if you differentiate with this time, what will get? 2x into dx by dt, right? Chain rule. Then 2y into dy by dt, but this is 0, and therefore the x dx by dt is always 0. So now, what is dx by dt? Can you guess the dx by dt? What is this? What is dx by dt?
So 2 meter per second.
Exactly. That is the rate at which the a is moving. So this is representing the va. Now, because of velocity of a, can you tell me x is growing or decreasing? X is increasing or decreasing?
Increasing.
So
increasing.
when the variable increases, we write plus va. So that's why I have written va. And dy by dt is we are looking for. So as the b will go down, the y will decrease or increase.
Decrease.
Decrease.
Correct. So the vb we write as minus dy by dt. So we can write here minus vb. So we have relation x va plus y minus vb equals to 0. So you got vb, how much? So vb is how much? Solve this equation. X va. Okay, I'll let x va minus equals to 0. So we got vb equals to x by y va, right? So now I got the answer. X is given as 5. And if x is 5, then at that instant, what is y going to be? 12.
12.
And what is va given? 2.
5 by 6.
So answer is 5 by 6 meter per second.
Sir, I did by directly chain rule. I did that first. I took the
So can you show the previous
dy by
page?
dt equals to dy by dx into dx by dt.
Yeah, that's fine. What you did again, just wait. Yeah, tell me what you said.
Sir, what I did was dy by dt equals to dy by dx into dx by dt.
So what is dy by dx then? What is the dy by dx? So what is dy dx then? If you are writing that way, then?
So it is, yes, that only I'm asking. Sorry, is it correct? So it is x plus something something. So it will be one only.
No, no, you do not know the relationship between y and x. No? So you first need to find the relation, then differentiate.
Sir, we took
So
x is equal to 5 and
Uh,
y is equal to 12. So
no,
x
no,
plus
no, no, no,
7.
no, 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 you can't write like that. X and y are first. Okay, I will tell you something very interesting. In the problem of the rate of change, the instantaneous values are not the variables, not the constant. They are variables actually, and you substitute the value to find the answer of that instant. So x is 5 is the instant when x is 5, you have to find the VB. Okay. So first you need to realize that as time will pass, will x going to be constant or will it change? As the latter will move further, the x will change or remain constant. Tell me. As latter will move, x will be fixed or x will change. Hello, hello. I'm asking something. Someone
so what
respond to what
was the question?
I'm asking. Question that as the bottom rod will move towards right, the x will change or remain constant.
So it will
Change.
Y will change or remain constant.
change.
Change.
So x and y are variables or constant.
Variable.
Variable.
Variables. So when you know that these are variables, so you need to differentiate those variables by finding the relation between them. So I knew that x and y are my variables. So I found the relation using Pythagoras, and I knew that the right hand side is not going to change. So when I differentiated with respect to time, I got a relation which is written on the bottom of the right side of the board. You can read there, and from there we got the answer. Okay. And once we have the answer, then we substitute their instantaneous values as given in the problem. So you can see that we have given 5, from there we got 12, and then we got the answer. Okay.
Sir, please will you show the
So what did you do after finding the relation?
So substitute the value. So once I have the relation, I know x is given 5, and
Oh,
if x is 5, yeah, if x is given 5, this is 13, so we can get this value y is 12.
okay.
At that instant. So when x is 5 at the instant, then y is 12 at that instant. So we substitute value, we got the answer. So this is the answer of that instant. That's it. It's not for all time. So as time will change, it will keep on changing, right?
So this is for 1 second, no? For the first second.
Not first second. It's a value at instant when the bottom is 5 meters away. And you may write like this also. You can write like L square minus x square, like this.
hello, sir.
Yes.
So please will you show the before slide?
Yeah, you can take a screenshot and then you can keep on watching it again and again. You can take on a phone or on a camera, and then you can keep on watching it because okay, this is the better way of doing it.
So
Sir,
Yes.
you added dx by hello, sir.
Yes. Yes. Tell me.
So you added
See, dx by dt is the rate of change at which the a is going away from the origin. So we write dx by dt equals to 5.
so that x square plus y square
Sorry,
is equal to L square, with what respect did you differentiate it with?
time. Okay, 1 second. Look at this. X square plus y square equals to L square. So d by dt of x square plus d by dt of y square d by dt of L square. I cannot differentiate x with d, so I will add dx square by dx into dx by dt plus d by square by dy into dy by dt. And L is constant quantity, it will not change, so it's 0. Okay. So this will give you 2x into dx by dt plus 2y into dy by dt equals to 0. So 2 will cancel out, and so you will have a relation. Now dx by dt is the rate at which the a is approaching, a is going away. So this is va, and dy by dt is a negative quantity. So we can see that as the rod will go right, the top of the rod will go down. So as time will pass, y will decrease. This is minus vb, because what I have said, the vb is the negative of change of y.
So can you give one more question to solve?
Just wait, we haven't finished this question. So now you can get the answer. Okay. Now in the same question, can you see the area under the rod and the x and y axis? Can you see the area? How much area? Can you see the area?
So the area will be
Will be how much?
Half into
Half
x to
into
y.
x into height.
it will be same after moving. No.
In general, when the bottom is x away, top is y away, what is the area of the triangle?
Half xy.
That's it. Now my question is simple. If the area is half xy, so as the rod will slip further and further, the area will change or remain constant.
Change.
Very good.
So remain constant, right?
Constant. What is the area now? And what is the area here?
Yeah, so it will change.
So I hope that the area will change, right? So when it is almost vertical, the area is 0. And when it is almost horizontal, area is again 0. So when the area is going to be maximum, that's the question.
When x,
Area is
y,
half,
x and y is equal.
area is half into x into y. If you want to write in one variable, you may write as x into under root of L square minus x square. Okay. The question is when the area. Okay, first of all, my question is simple. I will move this part. Question is, what is the rate of change of area? What is dA by dt? Can you explain? What is dA by dt?
So we can do it by in the right hand side it is half xy. So first we'll
Yeah,
relation in the relation we will apply dA
use
by
the use the chain rule and differentiate. Find the dA by dt. Again for the same question. When x is 5, what is the dA by dt? Tell me the answer. When dA by dt is half xy, then what is the dA by? So when a is half, sorry, when x is 5, at that instant, what is dA by dt?
So 15 meters per second.
How much you got?
How much you got? 15.
15. Okay, let me check. Is it positive or negative? Minus 15 plus 15?
So some mod of 15.
No, no, we have to find the with sign. We have to find with sign. Don't take mod. So Oh, you just differentiate this. Come on, guys. You're not able to differentiate with us. So d by dt of xy. That's it. Which you can write as half x dy by dt plus y dx by dt. That's it. Chain rule. And dy by dt is minus vb and dx by dt is va. We know already. Now substitute value minus this is 5 and this we got as how much we got minus vb? 5 by 6. So 144 minus 25 is how much? Tell me guys, what is the value of 144 minus 12, 25?
114. Oh, sorry,
1 1?
119.
119. Okay, fine. So this is the answer. So the rate of change of area means you have to differentiate with time and then substitute the value which we have already obtained. That's it. Understood? No.
It is
Yes.
9.9 something.
Yeah, whatever.
9.11.
Yeah, you can leave as a fraction.
So not 1 1.
It's a roughly 10. That's it. Roughly 10, right? So I can say 9.9.
Can you explain this
9.9.
calculation again?
Okay, how I did the addition?
ऐसा मतलब starting से.
अच्छा dy dt तुमने क्या निकाला बताओ? What you got this for this answer?
Sir, like पहले.
हाँ पहले वही same question है ना. We are solving the same question with new constant. So I'm asking the rate of change of area now. Okay, you can do this way. Okay, if you're not interested in doing this way, you can do other way. We can add area equals to half into x into y, but y we can replace by. Now, what is given to us? If you remember what is given to us, we have given dx by dt, which is 2 meter per second. This is given to us. Okay. So now, if I differentiate dA by dt, you have to use the product rule with time, not like this. So, how to say so many things. So we can take first part. So take x outside and differentiate the second. Take this outside. But again, in the first case, this is known to us. We will leave this, but this we have to differentiate with x. And this is known to us. This is called the chain rule, right?
Yes, sir.
So I'm doing my method too. Instead of two variables, I have used only one variable. So you get
So is that X?
this is x into this differentiation. This is two. So okay, anyway, this is a complex differentiation. You can leave this part. If you find it's difficult, you can leave. Then we have okay. So we have third method as well, which is very interesting. So we have L, we have theta. Let's say this is theta as a variable because theta is changing, right? So we may take theta as a variable. So before I go to third, I'm asking the same question. Can you tell me what is d theta by dt?
Sir, fine.
Again, see, I will tell you something. Okay, you're not getting the idea how to do it actually. There is a way of doing everything. If you look at every question, try to understand the concept, the pattern. They are asking something like find dy by dt, find dx by dt, find something, something. So whatever they're asking, you need to take that as a variable, what they're asking, and then try to relate that variable with the given variable, given values. Okay, like I know that I have given dx by dt. So I will make x as one variable, and I was asked in the first question, what is dy by dt? So I took that as another variable y, and then I used the Pythagoras to relate the variable, and then I differentiated to get the answer. In the second question, area, the rate of area, they were asking, what is the rate of area, change of rate of area. So we took the area formula in terms of x and y again, because that's easy for us to write. And then we differentiated that entire formula and we got the answer.
So
Now
sine
here,
inverse
now
12
here,
by 15 is equal to dt.
So can we use polar Cartesian coordinate, which is x is equal to r
So
sine?
sine inverse of x upon y, मतलब differentiation of sine inverse of x upon y with respect to dt.
no, why using sine inverse? I don't know.
So theta to sine. Theta.
Yeah, so to start with, okay, what are your variables? Tell me the variables.
Sir, x and y.
So what is the relationship between x, y, and theta?
Sir, x square plus. Oh, cha. Sir, x and L. Sir,
So
x
you
is
want to
the
take,
height and
yeah. So if you want to take the x and L, then what is the relation between these two?
sir, sine inverse of x upon y.
Oh my God. What is the relationship between, what is x here? What is x?
Height.
The bottom, right?
Sir, no, that.
You
That
are, you're
sir,
taking x here, you're taking x
that.
here.
Yes, sir.
But that is not noise, no? Because see,
So then we can use cos inverse.
yeah. We know that this is the rate of change of this variable is given to us. So you have to use what is given to you. This is given to you. So you have to exploit this condition. So whatever is given to you, you have to use that. So now what is the relationship between L, theta, and x?
Cos inverse of x upon y.
Yeah, so you just write, don't write inverse, just write the relation between that cos theta. So say cos theta equals to x by a. So x is L cos theta, right? Now L is variable or constant?
Variable.
Variable.
L by L.
L constant.
So L constant.
So if I differentiate, I can take L outside. So what is the d by dt of cos theta
Minus L sine theta.
Minus L sine theta.
into
d theta by dt.
Because cos you can differentiate with theta only, and then differentiate theta further. So this is what we are looking for. So my question was, what is d theta by dt, and you got the answer how much? Dx by dt upon minus L sine theta, right? So I may write VA by L sine theta. So I got the answer. Now sine theta is how much at that instant when I'm asking the question, when x is 5 and L is 13, what is sine theta? This is 12. So sine theta will be how much? 12 by 13.
Yes, sir.
So can we write this as minus 2 upon 13 into 12 by 13? So we got minus 1 by 6 radians per second. That's the answer. It means the theta will decrease at this rate, because as the rod will slip down, theta will decrease. That's very much obvious. So negative is saying that the rate is negative, it means it is decreasing. When the rate is positive, we say growing value, increasing value. So d theta by dt is minus 1 upon 6 radian per second. Okay. So in a given question, the rate, when they ask, how we begin actually, first we try to find for the relation of the unknown and known. So we assign unknown from our side. So we choose x, y, theta. This is what we develop on our own. It is not someone will tell you that think x, think y. This is how we start with. So we always look for we create variables which is called suitable variables, and we relate them. We differentiate with time, and we get the answers. Okay. So coming back to the method 3, in the same question, if a rod is again going this way, and the same question, I'm not changing the question. Okay, and this is x, this is y. I always choose x and y if possible. So what is the, when x is 5, then what is the, I ask what is the theta? Now the question is, if x is 5, what is the rate of change of area? What is dA by dt? So we got the answer by the really long method, if you remember, but we could have got the answer much easily. Like if I say this as theta, then I can write area as half base into height. But I can write x further as L cos theta, and I can write y further as L sin theta. So what we got the area of eventually is L square by 2, or maybe I can write 2 here and 2 here. It becomes L square by 4 sine 2 theta. So now what I have done is I have reduced the variable from a to and only theta. So I have only one variable theta. So what is dA by dt? So d by dt of sine 2 theta. So dA by dt is
So cos 2 L square by 4 into cos 2 theta into
so cos 2 theta into, and we can take 2 outside from the, when you differentiate this term with time. This is the chain rule, right? Because it's a sine 2 theta, so it will become cos 2 theta, and then differentiate 2 theta with time. So we get 2 times g theta by dt. So you get L square by 2 cos 2 theta into d theta by dt. And
So, sir,
yes,
so it will be
sir,
1
uh,
over 9 upon 12.
sir, I was not able to hear you.
yeah, tell me.
So I was not able to hear you.
Okay, okay. So now here we have to differentiate this using chain rule. So this is the what is the, this is the
So
chain
not
rule.
that. So from after you wrote that area is equal to half into x into y. After that, I
Okay,
was
okay.
not able to
From
hear.
here,
Yes, sir.
so I can replace x by this value, right?
Yes.
And this will become this formula eventually, and then you differentiate. So
Okay.
the differentiation of this will give you this much answer. So okay, I got cos 2 theta. So because cos theta is known to me, so I can write this as 2 cos squared theta minus 1 if you know the trigonometry. So L square by 2. L square is how much? So I'll write L square by 2. Cos theta was x by L. So I can write x square by L square minus 1. And d theta by dt, though we just got the answer recently. So dA by dt turns out to be something very big. Okay, what I'll do, I can multiply L square by 2 inside. So, in fact, 1 by 2 I will take this. So 1 by 2, I can take L square inside. I'll write 2x square minus L square. And d theta by dt is minus 1 by 6. 2x square. What is x square? So x is 5. 25 minus 30 square. So what we will get is 1 by 12 into 13 square minus 50, which is again, so we're gonna meter square per second. Area unit is meter square per second. Now it is clear, guys. So
Yes,
I
sir.
have not tried many problems, or rather, see, the dy by dx rate measure problem. How it comes is like it's actually difficult. It's difficult in a way like it's difficult to understand that what to assume first. Okay. So with time you will realize that the assumption of variable is the most trickiest part of solving such problems. So I hope that in tutorial you will solve more of the problems to get the better idea. Okay. So the concept I have taught, and now into practice. So I think the in the next tutorial session you will get more problem of this, which you can practice to understand. So it is like you have to convert the problem into mathematical statement from your own ideas. So I'll give you last problem. This is a very famous problem. Like problem is we all love flying kites. Anyone who doesn't know? So we have something called pulley, or you can say whatever you name it. So let me draw a diagram like this. And this is your the manja. The reel is there, you can see. And now we have a kite. So let me draw a beautiful analogy. Good. Okay. Now, all right. So we have got the kite. So now, what is the question here? Question is the kite fly at the constant height. So the center of the kite where the thread is attached and the bottom. And just make it a little- So this height is constant in value. It's not changing, even though kite is going forward and forward. So this is, let's say, maybe 50 meters above the ground is okay, and that's fine. So now you release a thread. Okay. So the thread is released at maybe 1 meter per second. That could be, yeah. So imagine, okay, leave this. Please, I can ask the question in the reverse way. The kite is going forward towards the right with 2 meter per second. This is the question. This is given to you. So kite is going towards the right with 2 meter per second. The y is fixed 50 meter. Can you find the rate of release of the reel?
Yes, sir, it is
Rate,
same like as first question.
yeah, rate of release of reel.
So any other the distance of
Yeah. You have to find the rate of reel when the kite is at a distance of 100 meter. So at this instant, this is the instantaneous value. At this instant, when x is 100, then find the rate of release of reel. So now you have to realize that as kite will go forward, the length joining the kite center and the reel will increase. So here the hypotenuse is variable, right? So can you guys guess the what is variable here? X, Y, or L?
so where is L?
L is, you have to think. This is L.
Okay, so
So is L variable or constant here? Tell me.
constant, so because means the length of the means the kite is moving.
Sir, L is variable
So but
and
Yeah, L is variable.
so then 50 meter will be
Yeah,
50
50
is
meters is
constant
constant.
and
Sir,
X is
but
also,
sir,
no, X is fine.
see, after some time the L will look like this, right?
yeah, sir.
So L is not constant. Y is constant here. Here I have changed the variable. So again, but the relation remains same. So I can always write this as 50. This is L. This
So
is
we'll
X.
try, sir.
Yeah. Okay. Go ahead. So what is given here? Can you tell me what is given here without solving first? Which rate is given? Which rate is given?
Sir, so which rate? What do you
Sir,
mean?
so EX
What is
by
okay?
Rate
Yeah.
of sir, rate of
What? Yeah, correct. So 2 meter per second represents dx by dt.
so
2
how
meter,
dx but yeah, sir, dx but yeah.
yeah, because anything horizontal is x, no? So how at what rate the kite is going horizontally, that I have taken x, so I can say dx by dt is the 2 meter per second, and you're supposed to find dl by dt. That's the only question. So I hope this you can do. Okay. So my other student has come. Okay. So okay, just you have to wait for some time. You can re-log in after maybe 10 minutes. Okay.
क्या
Can you join after 10 minutes?
10 हाँ 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 चलेगा
ठीक है, मैं अभी इसको फिनिश करता हूँ.
हाँ 10:45 तक मैं ज्वाइन करता हूँ.
हाँ 45 तक आ जाते. So you will meet someday this student which just left. So he is also in class 11, just like you guys, but he has finished everything. So he's finished all 11, 12, everything. Done?
Sir, 2 minutes.
Yeah, take your time. Not in hurry. I have given him 10-15 minutes.
Sir, can you explain the question once?
Question is, yeah, the kite is moving horizontally. Kite is moving horizontally with a rate of 2 meter per second. So the horizontal displacement of the kite is changing at 2 meter per second. So the question is, at what rate the reel is released? Okay, so kite will only move when you release the reel, right?
Yeah.
If you have flown the kite, you must be doing this.
So what is x is equal to 100?
You have to find, at that instant you have to find the value. Like when x is 100, then what is the dl by dt? Question is simple. Find dl by dt when x is 100. So x is a variable in general, but you have to find the dl by dt when x is 100. Okay.
So your minus sign will not come because nothing is decreasing here, right?
Yeah, exactly. Right.
Sir, is it 4 meter per second?
Let me check.
Sir, your dy by dt is
Y is constant here, no?
so dy by dt is constant, so it will
Zero,
be
zero.
0, no?
Yeah, right.
Sir, then I think 4 meter per second will be. I think.
Okay. So I can add x square plus y square equals to L square 2x dx by dt plus 0 is 2 dl by dt. So I get 2l 2 L dl by dt, and then we can add 2x is 100, dx by dt is 2 into L is okay, L we have to find, which is under root of 100 square plus 50 square, right? And this is what we are looking for. So what we got is dl by dt equals to 200 upon 50 root 5, which is,
Then I got 4 upon root 5, which is 4 root 5 upon 5.
yeah, that's fine. That's perfect answer. That's correct answer. Very good. So the rate, like this chapter called rate measurer, it's very interesting way of relating variables, and by differentiation method we can relate things which seemingly looks unrelated. We can actually relate. So this kind of practice will help you a lot in physics. Like you will become really good with physics if you can work more on this. So I expect more question on the tutorial where you can practice more. I'll also try to give you some question. I have some collection. So from there you can also practice, and then we can ask doubts. So with this particular
So the
topic,
maxima minima questions, sir, they are still remaining yet because they are 40
yeah,
something.
no, maximum I can practice slowly. Take every day, take at least 2 to 3 problems. So even if you take 2 3 problems every day, you will be able to finish, or at least uh, practice as much as in next 1 month. So not 1 month, I think 2 3 questions means how much you need, just 10 to 20 days.
Yes, sir.
Okay. So make small targets, but try to accomplish all those of targets in a given time. That is how one should learn.
Sir, I have just one doubt in calculus this whole. Sir, the partial derivation.
So what is your doubt? If you have
So
some
can you, I
problem,
mean, sir, can you solve just one question, then I will.
okay,
The
fine.
cos,
I'll solve.
Sir, like
x square
sin
plus
xy or cos xy.
Tell me how much?
so
Sir,
cos x square plus a square equals to y.
Cos
X square plus a square equals to y.
cos x square plus, like I don't know how you're saying it.
So cos
Put
of
the
x square
bracket.
plus a square.
Okay, like this.
so
Cos
first, can
of,
you solve a simple one then?
like this. Like you can explain, like you can read out the question properly. I can write it here.
Sir, can you solve one first simple question?
Okay. Wait. Let's say I'm writing x square
Sir,
y
can you show the
plus.
first one that you like sin xy?
Okay. So let's say okay. So let's say x sin xy. Okay, you are sin xy plus y square x plus anything. Just write anything x uh, cube y. Okay, because 10 x. Yeah, fine. So let's say we have this expression, and what I'm looking for is find dy by dx. Okay. Formula says dy by dx is minus del z by del x upon del z by del y. Okay. Now this is the formula. And now I have to first find this part and this part separately. To begin writing this way, first I need to bring every term on the one of the side. So I can bring either everything here on the right side by putting minus, or bringing this. You can choose whatever. So I can name it z. So z is when you bring everything on one side. Okay. So z is when you bring everything on the one side. It looks like something this, because now the other side is 0. So I just don't write it. So this is how we create a z out of the expression. So a z is not given to us. What is given is this value. From here we get z. And now we use the partial derivative. So we write del z by del y. Take each term. Sine will give you cos value. So when you differentiate with y, x is constant. So x will come out as a, or you can say, you know what is this is like. Plus del by del y of y square x plus del by del y of x cube y minus del by del y of 10xy. Because y is the variable here, so everything which is not y will be taken as constant. So this is outside because of chain rule. So x will come outside, so we can x cos xy, and then y of del y by del y is 1. So that's, you can say 1. Then x is outside, del y by del y square plus x cube is constant, so del y by del y. Then x is constant, del y by del y. So now what you get is x cos xy plus x into 2y plus x cube into 1 minus 10x into 1. That's answer. First part. Similarly, I hope you can do for the other part. X. So to find del z by del x, what you can do? So you will write del by del x of sine xy, but this is first you have to use a chain rule. So you will add this
Okay,
into,
sir, understood.
yeah. So now you can do it further.
Y cos
Sir, but minus sign will also come.
Pardon?
Minus negative sign.
Yeah, this we have this.
Brother, you gave us the
Sir, I was confused in it because when you started that give an example of sin xy, sir, I got it wrong. That's why I thought. And I didn't have the video link, so.
Okay. So I think videos are available on YouTube. I think you can ask Amit sir; he will help you. If you want to revise something, then you can ask sir. Sir will definitely help you in giving the link and something. Then you can watch, and yeah. So that's the purpose of entire this recording of the video lectures. You can go back, you can revisit and practice more. So rest, don't worry. I mean, sir will give you lots of problem on this part also, and you will practice. And still, if you have some doubt, then okay, of course, I'm always there. Don't worry.
Sir, can you go to the kite question? I want to copy that.
Okay, I'm sharing the notes because I have to other lecture. So I'll end the lecture. I'll share the notes on the group. You can copy from there. Okay.
Okay, sir. Thank you, sir.
Sir,
Yeah.
sir, I had one question.
Mhm.
Sir, key when we do dy by dx,
Mhm.
उसमें तो that the y is in terms of x, so we can differentiate it.
Mhm.
Sir, you were doing d theta by dt. So how are you doing that?
So the theta is of course something which you have to differentiate with respect to time. So first you need to realize that is theta changing or not. So answer is yes, it's changing. So at what rate it is changing? So answer is d theta by dt is representing the rate of change of theta with time. Okay. So we are looking for d theta by dt. At what rate theta is changing? So you are looking for rate. Okay. So d theta by dt represents the rate of change of theta, which is a variable here.
So can we
Okay.
add like dx by dx by 2
No,
with
you
respect to
can't
x by
write it.
2?
No, you can't write that way.
So why? Because x by 2 is also means representation
Yeah, yeah, you are saying x by 2 or x2. What you said again?
x by 2
Okay, so what you want to write?
dx by 2.
Yeah, you can write, not an issue. So you can write dx by 2 equals to dx upon d, so dx by 2 upon dx by 2 into d by dx of x by 2. That's interesting. So you'll get half anyway.
Yeah, sir.
So it doesn't matter. Okay, guys. So I'm leaving this. I mean, I have to end this class, else I will be late. Okay, bye, guys. Take care. If
Bye.
you have more doubts, you can ask in either tutorial or you can come back and ask me again. Okay.